Now, how do we get U and V transpose? So for that, we need to talk about the, well, first of all, the definition of an orthogonal matrix, the distinction of orthogonal and orthonormal, and then we will switch and talk about the Gram-Schmidt algorithm, one of the algorithms with which you can orthogonalize. This is a tutorial from week 1, which I have updated. An orthogonal matrix, sometimes synonymously called orthonormal, is a matrix that is whose vectors in the column space. Imagine you have a matrix. If you take the columns as vectors and you take the product, the dot product, also known as the inner product. So if we take the dot product of two columns in that matrix, and their value and the value of this product becomes 0, then we say that the columns of this matrix are pairwise orthogonal. What does it mean for the dot product of two vectors to be 0? Does anybody know? Like if you were to plot these two vectors and their product is 0, what would those two vectors look like? Precisely, they would be perpendicular. Just like we saw in that cosine similarity example. You would get this. Remember when we took the cosine similarity of, what was it, dog and building? The angle was quite big. But anyway, for two vectors to be orthogonal means that they have, well, they're perpendicular. If this was cosine similarity, this would be they have, little to nothing to do with each other. That's an orthogonal matrix. Its column vectors would all be orthogonal to each other, perpendicular. Now, in some literature, if you see here, in some literature, an orthogonal matrix is a matrix to which only the first condition applies. So an orthogonal matrix is only a matrix whose column vectors are perpendicular. An orthonormal matrix is a matrix to which both conditions 1 and 2 apply. What is condition 2? Condition 2 says that the magnitude of each column vector is 0. How do we calculate the magnitude? We've seen this before in one of the previous sessions. This is the magnitude. And, also it's known as a norm. These are synonyms. Typically, you want to use the two vertical bars. Sometimes you will see single bars, but this is not good practice because single bars are also used for the absolute value. Anyway, the way you calculate the magnitude of a vector is to take its components. Let's say this is a vector v over R4. It's a 4-dimensional vector. You take all 4 of its components, square them, and then add up the sum, and then take the square root of that sum. If that becomes 0, or if it becomes 1, then you have a unit vector. Essentially, unit vector is one whose radius is 1. So here, if I return to this other file, it's called orthonormal because its magnitude is 0. And there's a word called normalize. Normalization is where the largest component in a vector is 1 and the smallest component in a vector is 0. This is after normalization. I'll show you how that's done in a moment.